Hi, my name is Kristofor Sellstrom. I'm an electrical engineer at the University of Vermont.
Hi, my name is Akie Hashimoto. I'm also a senior here.
Today we're going to walk you through our senior project demonstration for wireless sensor networks, and our project's nickname is HoMeS, for Home Monitoring System. We'll show you through the demo here in a second.
Thank you.
Alright, so we decided on this project, and we designed this project because we've heard a lot recently about the smart grid technology, and what they've been really focusing, especially in Vermont, is putting what they call smart meters on people's homes, and this will give the utility companies the ability to monitor the power consumption in relatively real time on each load. So that'll give them a much better understanding of what the power grid is doing, since it's one of the most complex systems that man has created. So the smart grid, currently they're focusing on these smart meters, but what we wanted to focus on is to give the consumer the ability to focus on their internal loads, because the utility is concerned with you as a whole load, but what if you could reduce your load in your house individually, especially if they start billing by the if they start a more dynamic pricing scheme, meaning that if you look at the load distribution over, for example, for a day, you have this peak load, so they're going to start charging more, or they may start charging more during this peak time interval. But what if you could take this load and you can move it to non-peak hours? Okay, so then you would get more of a distribution like that, which is much better on the power grid. It's much easier for things to be managed. And if your load is over here, you'll be paying less because electricity in the off hours is cheaper. So what our project focused on is giving the consumer, first of all, the ability to monitor their power consumption on a device-by-device level. So we're focusing on the inside of your house, on your electric car, for example. And this will also give the ability to better integrate local renewable resources such as solar panels and maybe larger products such as wind power. So if you look at a typical house home, you have 2 or 3 outlets per room. Most places have even more now. So every one of those outlets you can monitor in real time. And what we focus on is larger loads for this project. We focus on, for example, a washer, a dryer, an electric car that you might want to plug in, refrigerators, gas stove, or electric stove, and maybe some lights, some bigger lights. So for this project, what we did is we used the EZ430, and you can see our little demo on the floor. We took an extension cord and a current sensor and strapped them all together. And what that gives us is extension cords with the ability to monitor the power consumption of the load that's plugged into them. And we're going to show you a little demo here. So we have our 3 devices that we're going to be monitoring right here. On the left we have a hot water heater, which can draw about 12 amps. We have a computer, which on average draws about 3 to 4 amps. And then we have this fan right here, which draws about 1 amp on full power.
So we have this graph on the top that's drawing about 2 to 2.5 amp, which is a computer that's turned on right now. The second line around 0.4 amp is the fan, and on the bottom is the teapot that's turned off right now. Now we're going to turn on the teapot, which draws about 12 amp, and now you can see the spike around 12 amp on the teapot. And as long as the water is boiling,
Until the water's boiling.
It will draw the current.
So as you can see from this visualization, we have the teapot's huge amount of power. So if you wanted to figure out, if you took the current, you want to figure out how much power this would be, you could take this whole thing and multiply it by 120 volts, and you would get the average power, or the power of that each device is consuming.
No.
So if you notice, it's kind of surprising actually how much your computer is drawing. It's drawing about 2 amps. So it's drawing quite a bit of power continuously when you're running it. And right now we're sitting here in Vodi, and there's 6 or 12 computers that are each going to be drawing around this much power. So if you could notice this and you could reduce this, turn off those active computers, you'll save a lot of power. Also down here you can see this fan. It's pretty steady in actually the power draw, which is pretty interesting, because we thought originally that the fan would have a more wavy circuit, but actually the computer has a fairly wavy circuit. And then as you see the spike for the teapot, our teapot's turned off now because it's already boiled the water. We didn't put very much water in it. But if it was boiling more water, it would stay high for longer. We hope you enjoyed our demonstration of our home monitoring system we nicknamed HoMeS. We have a few future things we'd like to do with the project if we had the opportunity. Some of these things that we've kind of sketched up on the board here: smart lights. If your lights get automatically dim depending on the ambient light in the room, you can save energy that way. We have, if we could build in the wireless device to the outlets themselves, we can relay all that data together. Having different applications for iPhones, Androids, Microsoft, Windows, all the platforms, you could have very nice user interfaces for these programs and allow the user to interact with them nicely. We also have some other things that we want to do, such as the automatic switch. You could control the object remotely from your iPhone or whatever.
This is definitely a prototype, but we got the proof of concept of measuring the current coming out of the socket, and we'll be able to demonstrate that we can see the differences and we can calculate how much current we're drawing. And in the future, hopefully, we can control the input of current coming in.
Yep, control your power consumption, help save the environment.
Yay!